Hello students, my name is Sumit Mehta. Today we will discuss about trigonometry. Okay, so we will see the relations between sine, cos, tangent, cosecant, secant, and cotangent of theta or angle A or angle C. I'll tell you what is the relation between all of these trigonometric functions. Okay, so let me start with first sine of A. Basically, it is a trigonometric function which is called as sine. In short, it is written as sin, but overall it is sine of A, angle A. So this formula is called as is known as perpendicular by hypotenuse. For a right angle triangle, in our previous lectures, I told you that this will be the side opposite to the right angle will be hypotenuse. Okay, and the side and the angle which you are taking and the side opposite to this will be called as perpendicular, and this will be called as base. So I'll write all the formula in terms of base, perpendicular, and hypotenuse. Okay, so sine A will come as perpendicular here is BC upon hypotenuse here is AC in this diagram. So if you see the diagram, this is the perpendicular. So our formula for angle sine A will be BC by AC. Let me write cosine of A. Cosine of A. In short, it is also written as cos A. Okay, so it is base upon hypotenuse. So base is AB upon AC. I hope you guys are clear now. The difference between sine and cosine is in the formula of sine, the perpendicular comes in numerator part. Okay, this comes in numerator part, but in the formula for cosine, the base comes in the numerator part, which means AB. This is the perpendicular, which is vertical line, and the base is the horizontal line. This is the horizontal line, and this is the perpendicular is the vertical line. So let me write the formula of tangent of A. Tangent of A can also be written as tan A, and I can directly write tan A is ratio of sine A to cos A, means the ratio of these two equations, first and second, and it is also can be written as perpendicular upon base. So if I apply this formula, sine A was BC upon AC and cos A was AB upon AC. Okay, so you will get BC upon AB, which is perpendicular upon base. So the formula you can directly use as perpendicular base, perpendicular divided by base also, or sine A by cos A also. I hope you guys are clear up to now. So let me write one more formula of cotangent A. Means it is also written as cot of A, and this is opposite to 1 by tan A. So what was the formula for tan A was, and it is also written as base by perpendicular, means opposite to the formula of tangent A. You can see here it is that reciprocal of tangent A. So what you will get, base was AB and perpendicular was BC. So this is the formula of cot A. Okay. So student, now comes the secant of A. It is a reciprocal of cosine A, or you can say that it is hypotenuse by base, which means it is AC by AB. Directly you can reciprocal the formula of cosine A. Now comes the part of cosecant A, it is reciprocal of sine A. So what was the formula of sine A? And you can directly write it as hypotenuse by perpendicular, means AC by BC. So these are all the formulas which I write. Formula of sine A is perpendicular by hypotenuse. Now I am writing in a short term. Formula of cos A is B by H. Formula of tan A is P by B, perpendicular by base. Formula of cotangent of A is B by P. Formula for cosecant of A is H by P, means opposite of sine, and formula for secant of A will be H by B, opposite of cosecant. Okay, opposite of cosine formula, sorry. So I hope you guys are familiar with all the formulas related to trigonometry of base formula. These are called as ratios formula, all ratios formula, trigonometric ratios. Okay, so we will do some example on this. So student, here is the question in which we are given as tangent of A is 4 by 3. As I told you, the formula of tangent of A is always perpendicular by base. So I have drawn here a diagram of triangle in which angle A is this, B is this, and C is this. So according to this, if this is a 90 degree, this will be our perpendicular P, okay, and this is our base B, and we are given as tangent of A is 4 by 3. So we can directly write perpendicular will be 4 times some constant and base will be 3 times some constant according to this formula. So we can write 4k and we can write 3k using Pythagoras Theorem, which I told you in my previous lectures also. Pythagoras Theorem, which states that hypotenuse square is equals to base square plus perpendicular square. So we have to find out here the value of h, which is equals to b square plus p square. So we know the value of b is 3k square plus 4k square, which is comes out to be 9k square plus 16k square. This is 25k square. So if you take the square root of this, it will come out to be plus minus 5k. But the side length of the side cannot be negative, so we will negate this. So answer is 5k. So our hypotenuse is 5k. Now you can find all the trigonometric ratios. So what is the formula of sine A will be perpendicular by hypotenuse. Now it is very easy for us. Perpendicular is 4k and we also know the value of h is 5k. So it will come out to be 4 by 5. And similarly for cosine of A, it is base by hypotenuse. So we know the value of base is 3k and the hypotenuse is 5k. So what we are getting is 3 by 5. So cos A is 3 by 5 and sine A is 4 by 5. Sorry, 4 by 5. So I am writing here again as sine A is 4 by 5, cos A is 3 by 5 and tan A was given to us as 3 by 4. Okay, I hope students you are clear up to now. Let me give you one more example on this, how to find the trigonometric ratios when we are given one angle or one trigonometric ratio. So student, here is one more example in which we are given as in a right angle triangle ABC. Let me draw the diagram first. This is a right angle triangle ABC. We are given the value of tan A. Tan A is always equals to, as you know, the formula. Okay, this is perpendicular by base. So perpendicular is this, base is this is base, this is perpendicular, and this is hypotenuse. Okay, So I'll, and this is given as 1. So what I can say, this is ratio 1 by 1. Okay, so in this case perpendicular is 1k and base is also 1k. Now we have to use the Pythagoras theorem, which states that h square is equal to p square plus b square, means hypotenuse square is always equals to perpendicular square plus b square in a right angle triangle. So we have to find the value of h, which is equals to 1 square plus 1 square, which is root of 2. So h is coming out to be root 2. So now we will find, and we have to verify that whether it holds or not. So let me write the LHS is 2 sine A cos A. So what is the formula of sine A is perpendicular by hypotenuse, and the formula for cos A is base by hypotenuse. So this is coming out to be 2 into perpendicular is 1k upon hypotenuse is root 2 times k into base is 1k upon hypotenuse again is 2k. K to k cancel out. So 2 upon root 2 multiply root 2, which is 2 upon 2. So this is coming out to be 1, which is equal to R HS, which was 1. So hence we proved that LHS equal RHS. So our question ends here. Let me give you one more example, one typical example on this. What can be the maths question come on this? So student, here is the question in which we are given the value of 3 quota equal 4. So let me proceed with the question. Then quote A will be 4 by 3, and as you all know, the formula of quote A is base by perpendicular. So I am drawing here a diagram where it is angle A, B, C. This is our base, this is perpendicular, and this is hypotenuse, and we are given the value of base is base by hypotenuse is 4 by 3. So base comes out to be 4k, this comes out to be 3k, and after using the Pythagoras theorem, this is 3k square plus 4k square, this comes out to be 5k. I did this in previous question also. So h is coming out to be 5k. So now you can find the value of tan A. Tan A will be 3 by 4, 3k by 4k, which is perpendicular by base. Okay, sin A will be p by h, which is 3 by 5, and cos A will be 4 by 5. Now we have to solve. Let me take the LHS, which is 1 minus tan square A upon 1 plus tan square A here. Okay, so this is, what is the value of tan A? 3 by 4 upon 1 plus 3 by 4. Okay, this comes out to be 1 minus 9 by 16 upon 1 plus 9 by 16. Let me take the LCM above as 16. So 16 minus 9 upon 16, 16 plus 9. This is 7 by 16 upon 25 by 16, which is 7 by 25. And let me solve the RHS part also. Here it is the RHS, cos square A minus sin square A. So what we were getting, the value of cos was 4 by 5 square minus 3 by 5 whole square. So this is coming out to be 16 by 25 minus 9 by 25, which is 25 LCM. 16 minus 9 is 7. So we are getting the value of LHS equal RHS. This is the most typical example which comes through this formula. So I hope students you are pretty clear up to now, and if you still have any doubt or any query, you can do comment in the comment section. I'll be more than happy to solve your query on this. Thank you, students.